Hello, this is a video on chapter 9. I hope you're doing well still. Let me start. Let me take a picture of there. And we're going to talk about these three sections right here in the text. And also I'm going to talk about basically how to solve systems of equations using matrices, which you learn in college algebra. But I'm mainly going to talk about how to solve systems of equations and systems of nonlinear equations. Some systems of linear equations and systems of nonlinear equations. So let's just start with the first section. So what I'm going to do, I'm going to just use some whiteboard here to talk about it. So let's say you are given this problem. If you have a number, if you add 2 to it, you get 8. Everybody knows how to solve this, right? You just isolate what? Isolate x, so you get 8 minus 2, so x is 6. So that's the only number that works. Now, what if you're given two numbers? So we are asked to find two numbers, and the two numbers add up to, let's say, to 15. Well, then we have many choices, right? For example, 2 and 13, 10 and 5, or 5 and 10, right? So there are infinite number of solutions to this. Those are, of course, ordered pairs that are going to be on this line if you graph it. Basically, what we are saying here in this equation is that what are two numbers that add up to 15? Well, in the coordinate plane, that would be just a line, right? So let me just, so x plus 15 goes through these 2 points on the x and the y axis, so that's what we're going to get. So every point here is a solution for that equation. Now, what if somebody says, okay, I want two numbers that add up to 15, and I want the difference to be 10, and I want, of course, these two conditions to be satisfied at the same time. Then we have a system of two linear equations with two variables, right? So two variables, two equations. Okay, now, if you think of all the points on this line and all the points on this line, then, well, x minus y equals to 10. When x is 0, y is negative 10. And when y is 0, x is positive 10. Remember, this was 15, right? So here is, let's say this is 10. It's not accurate, but, we get another line here, right? Now, this line and this line, they intersect at that point. And that point is basically ordered pair that not only satisfies this equation, but also this equation, right? So one way to solve a linear equations of two variables, system of linear equations with two variables, is to graph the two lines and see where they intersect. An intersection point is a solution. Now we can do that with the calculator. So let me use a calculator here. So with the calculator, we could just go to y equals to. Now, calculator graphs functions. So what we can do is, let me erase this right here. I don't know why it's so slow, but because it's a Microsoft whiteboard. All right, well, it's really slow. Okay, here we go. So what I have to do is I have to convert these to y equals to 15 minus x and y equals to, if I move the y to this side, 10 to that side, that would be x minus 10, right? So basically what I have is 15 minus x, and in y2 I have x minus 10, and then I go to zoom 6 and graph them. So it looks like it's off a little bit, so I'm going to change the window. So I want to go to the right a little bit more and up and down. Let me go back, see. So you see I want to go up maybe a little bit more, down a little bit more, and right a little bit more. So that means I have to change the x max maybe to 20, and I have to change y max maybe to 20. So I go up a little bit and down a little bit, so I put negative 15 for y min, right? And then graph. So now I have a better look at this. So what I want to find is that intersection point, and I can go to second, calculate, point of intersection 5, and then it automatically jumps on one of these. That's okay. First curve is that, yes, just press enter. The second is that one, yes, press enter. And it says, do you want to guess? Well, this is, if you have more than one intersection, you can move the cursor closer to what the intersection that you want. But here you go, okay, get it close to it, and then press enter. So intersection is at what? Is at 12.5 and 2.5, right? So that's the solution for this system of equations, right? Now, so a system equation can have one single solution. Now, what if we change this? So what I'm going to do, I'm going to change the problem to a problem like this. Suppose I'm looking for two numbers. You add them, you get 15. Oops, let me fix that. So you add them, you get 15. And if you add them, you get 10. Well, obviously, this is very obvious that this system cannot have a solution, right? Because how can two numbers add up to 15 and then add up to 10? But if we try to solve it, what happens? Well, if we try to solve it, we're going to get, so we are going to get, so if we want to solve it with graphing, so again, what do we have to do? We have to convert these to what? Y equals to 15 minus x, and y equals to 10 minus x. So if you put them over there, you know what's going to happen. You're going to get what? You're going to get, let's go to graph, and we get 2, well, I don't know what happened. Oh, I didn't put anything there. X. There you go. We get two lines that are what? Parallel. They can never meet, right? So this kind of systems of equations have no solutions. So basically this one has one solution. This one has none. Now, what if we change this to, and how do we represent no solutions? Well, we can just put phi, which means empty set, or you can just put an empty set like that. Means solutions is nothing. Nothing in the empty set. Nothing in this set. That means this is an empty set. That's the same as saying that. These are the same. And this is phi. Now, what if we change the problem to something like this? Let's say two numbers that add up to 15, and if you multiply one of them by 2 and the other one by 2 and add them, you get 30. Well, now, if you try to solve this, we are going to get what? Well, now I have to convert this to y equals to 15 minus x, and this one is going to be y equals to 3 minus 2x in parentheses, and then divided by 2, right? So that's what I'm going to put in there, and I'm going to put 15 minus x, and over here I'm going to put parentheses 30. There you go. So 30 minus 2x divided by 2. All right, so let's graph this. So here's one line. Where is the other one? Well, the other one is the same one. You see, if you change this to, let's change that to, I'm going to change it to graph it with a little, you see, if I change it to that little key looking thing, then the way it graphs it is, it goes over it with that thing. You see that? So that's the second line, and we know it's the same line, right? So what's the solution? Well, the solution would be every point on this line, right? Because they're both what? Both lines are actually the same. So anything that works here, it works here too. For example, let's say 10 and 5. 10 plus 5 is 15. 2 times 10 plus 2 times 5 is 30. So this system has many solutions. So one, none, or many. All systems of equations have either one, single solution, none, or many. In this case, has many. Now, the way we write this is the solutions here. We write a set. We say the solutions are all ordered pairs such that the x plus y has to be 15, and that's it. You could put 2x plus 2y equals to 30 here. Doesn't matter. We usually write the simpler equation here, and that's it. That's how we solve these using graphing, right? Intersection of two lines. Now I want to talk about algebraic way of solving these systems. So if I have x plus y equals to 15 and x minus y equals to 10, not by graphing, but just how else can I solve this? Well, we can call this equation number 1, we call this equation number 2, and try to see if we can get an equation out of this that has only one variable. So that's called the elimination method. Elimination method is a method that tries to get rid of all the variables except for one and see what that variable is, and then substitute back and find the rest of them, right? So here we are lucky because this is very easy to solve using elimination method. So we're going to take equation number 1 and add it to equation number 2, right? So basically x plus y. So how do we add two equations? Well, we add the left sides, and then we put equal sign and add the right sides. So here's x plus y, and then plus x minus y equals to 15 plus 10. Now here we get 2x equals to 25. So x is 12.5. And that's the same x that we found by using graph, right? And then we take this x, so we take x equals to 12.5 and sub in what? Sub either in 2 or in 1, doesn't matter. Let's put it in 1. So what we get 12.5 instead of x plus y has to equals to 15. So y equals to 15 minus 12.5, which is 2.5. So the solution is 12.5, 2.5, and that's exactly what we got by graphing. Okay, now another way to do this is called substitution. So let's talk about that too. So I'm going to redo it, right? Let me see. We can go a little bit further up. Looks like doesn't want to do it. Okay, well, it's good enough for space here. All right, so x plus y equals to 15. X minus y equals to 10. There's a system. So again, we call this 1 and 2 equations. Now, another way to solve this is to solve one variable from one equation. For example, here, we can solve for x. So solve for x in equation 2. Now, what do we get? Solving for x, let's just move y to the other side. So x equals to 10 plus y. And then we're going to take this and sub in equation number 1. So what do we get? Equation number 1 says x plus y equals to 15, but our x is that. So this is x plus y equals to 15. So that's 10 plus 2y equals to 15. So 2y equals to 5, so y equals to what? 2.5, which is the same answer we just got, right? Now, we have y equals to 2.5. Now we can have x easily here. So what is x when y equals to 2.5? Well, x would be 10 plus 2.5, and that's 12.5. So it's the same ordered pair, right? But using a method that is called substitution. So we take one variable, solve for it in one equation, and substitute in the other equation for that variable. This way, we only have one variable to deal with. You see that? This equation has only one variable to deal with. Okay? All right. So substitution, elimination, or graphing. That's how we can solve it. Now, of course, you knew all that already, right? So what I'm going to do, I'm going to see if I can get this up here. So what I'm going to do, I'm going to use something is called matrices method. Now, first, we're going to just remind you of what matrices are quickly. So a matrix is actually a multidimensional number. For example, this matrix has 2 rows and has 2 columns. And I'm sure in college algebra you learned how to multiply matrices, but you can read the text, it reviews it. But this is a matrix that has 2 rows and 2 columns. And the dimensions of the matrix are written as rows by columns. So 2 by 2 means 2 rows and 2 columns, okay? And then this matrix here is a matrix that is 2 by 1, right? Now, the way we multiply 2 matrices is by multiplying rows by columns. How? Well, let me first tell you what we get here. We can only multiply 2 matrices if these two are the same. Why? Because that's number of columns of this one, and that's number of rows of this one. And if you multiply row by column, then you have to have the same number of numbers. because the way we multiply, let me do some scratch work. So the way we multiply row 1 by column 1 is by taking 1, 1, and multiply it by x, y this way. We multiply 1 by x, so that's x, then plus 1 times y is y. So this number, right, goes in the answer. Now the answer is 2 by 1. So the answer would be 2 by 1. See? So it has 2 rows and has only 1 column. So this number is going to go here. So if I want to find this row 1 and column 1 of this answer, I have to go to row 1 and multiply it by column 1 this way. So this answer is x plus y because we don't know what x and y are, so we're going to write it as x plus y. And then the second one would be this row times this column. So it would be row 2 times column 1 of the second matrix. So that would be 1, negative 1 times xy. And that would be 1 times x plus negative 1 times y, which makes it a negative y. So I have to make this a minus. So it would be a minus y. And this goes here. All right, that's how much you should know about multiplying matrices. That's all there is to it. If it's, the dimensions are larger, it doesn't matter. You still do the same thing. You just have more entries here. Now, also you have to know that if two matrices are the same, let's say A, B, C, D, it has to equal to, let's say, C, D, whatnot, E, F, G, H. Then for two matrices to be equal, all the entries, all the elements have to be, corresponding elements have to be the same. So this element is in row 1 and column 1, and this element is in row 1 and column 1, so they have to be the same, and the rest of them. So two matrices are equal if the elements are equal, corresponding elements are equal. Okay, so how do we use this idea to solve a system of equation? Well, the way we do it is like this. So let's see. So suppose we have the same system. X plus y equals to 15 and x minus y equals to 10, right? So how do we solve this using matrices? Well, first we write it as a matrix equation. What do I mean by that? I mean, if we write the coefficient of the variables in order, so if you write this equation as x first and then y second, this has to be x first, y second. And all the numbers, we write them on the right. So all the variables are here, the numbers, they add up on the one side, like that. Okay, so the coefficient of this is 1, coefficient of this is 1, so they go here. And the coefficient of this is 1 and coefficient of this is negative 1, so they go right there. And then if you multiply by x, y as a matrix, like this, and then the right-hand side, you put those numbers like a matrix of 2 by 1. Then as I just discussed, if you multiply these two, you get a matrix that is 2 by 1 and is x plus y and x minus y. And we have a matrix here which is 15 and 10. And for these two matrices to be the same, this has to be equal to 15 and this has to equal to 10. So what happens as a result of this equation? We get the system back, right? So that means writing a system of equations in terms of matrices, this is equivalent to that. And a good thing is that if we can, now that, so let me erase all that. 6. Okay, so what I'm going to do, I'm going to erase everything. And here we go. So the good thing is that if I have something like this, right, I can write it as a matrix equation. 1, 1, 1, negative 1 times xy equals to 15 and 10. Now notice that if I can somehow convert this matrix equation to a matrix equation that looks like this, and then I have over here I have some numbers. I'm just going to put triangle and a square for numbers. Then notice that if I do the same thing I just did, if I multiply, on the left, what do I get? I get 1 times x, 0 times y, and add them, I get x, right? And here I get 0 times x, 1 times y, I get y. And so for these two matrices to be the same, what has to be true? X has to be that number and y has to be that number. That means if I can somehow convert this to a matrix equation like this, then I can solve for x and y easily. And that's what Gaussian method is. The Gaussian method is to turn this into something like this so we can see what x is and what y is. And basically that's the idea of elimination. If I add these two, right, what do I get? Well, if I add these two, y goes away and I can find x. So to eliminate variables, what do we do with equations? We can add them and get rid of one of the variables. And notice that if we have, let's say I had something like this, 2x minus y equals to some number. And then I had, x plus y equals to some other number. Now, plus 2y. So here, adding doesn't cut it because if I add them, I can't get rid of y. So what I have to do, I have to multiply this equation by 2 and then add it to this one, right? And that's the idea of multiplying an equation by something and add it to the other one. Now, instead of working with equations, we can work with rows of what? Rows of a matrix and do the same thing. So notice that here, how do we get from here to here? Well, we have to get rid of this number. How do we get rid of this number? We have to take this row and subtract it from row 2 to get this, right? And that's how we can get rid of these. Get this 0. But in order to get this 0, then you have to continue. So let me show you how to do this quickly. So let me clear this one more time. And so suppose I have the same thing, x plus y equals to 15, and x minus y equals to 10. So what we do first, we are going to write this as 1, 1, 1, negative 1, and just to make sure we carry the other side of the equation as well when we add and try to get rid of variables, we're going to add them here. This is called the augmented matrix. Augmented because what we did, we augmented this matrix and added another column to it. So my goal is to take this and make it look like something like this, 1, 0, 0, 1, and then some number here and some number here. If I can do that, then the system is solved. Now, I'm sure you learned in college algebra how to do this, so I'm not going to go over it here. I'm just going to show you how to do this with a calculator quickly. So with the calculator, what we are going to do is we're going to go to matrices and then go to edit. So go to matrices and edit, and then make this matrix this size. So it's 2 rows and 3 columns. See, 2 rows and 3 columns. And then we're going to go down to the matrix and just put these numbers in order. 1, and then press enter. 1, press enter. Then 15, and press enter. And then notice that it jumps to the second row automatically. We'll go 1, enter, then -1, enter, and then 10, enter. Now, once we have the matrix in there, if you go to matrices, don't go to edit, just the first one. Pick the first one, fetch it, put it on home screen and press enter, and you see what's in it, right? So what we're going to do is this. We can go to matrix again and go to math and go down and find something called RREF. Now, RREF stands for row reduced echelon form, which is this right here. So the calculator is going to take these rows and starting from this number, is going to take this row, subtract it from here to make this 0. Then it's going to use this number to make that 0 and get it like that. Now notice that this is if it's a 50 by 50 matrix, this process takes a long time by hand. So technology helps us to do this. So let's do that. So we got RREF and put it on home screen. And then we put the matrix that we want to do that to, which is A. And then press enter. Notice that what we have is what? Is 1, 0, 0, 1, 12.5, 2.5, just like magic. And now we know that this is really what? Is 1 and 0 here. So if I want to convert that to a system, it will look like this. 1 times x plus 0 times y equals to 12.5. And 0 times x plus 1 times y equals to 2.5. And obviously, x is 12.5 and y is 2.5. So you see, it's very easy to solve using Gaussian elimination method. So it works for 3 by 3, for 4 by 4, for any matrix, and I'm going to show you some examples. Okay, so what's another way to do this? Another way to use matrices to solve systems of equations would be to, here I do want to erase it this way. So it looks like so far is working. All right, so now another way to do this is to think of a matrix like this. To think of a matrix like this. Think of 1, 1, 1, -1 times xy equals to 15 and 10. And then so this is like A times, let's say capital X is just this matrix. Because we can name a matrix capital X. So this is A times X equals to, let's make this B, matrix B. So that's the matrix B right here. And this right here is A. And this right here is X. Now, you know, if I have 2x, let's say I have 2x equals to, let's say I have 2/3 x equals to 5. How do I solve for x? I multiply both sides by what? 3/2. And then this would be 1, and we have the answer. Now, it's the same kind of idea, except for instead of using I can get this. Instead of using numbers, we use matrices. That's the same kind of idea. So here, what gets rid of A is called A inverse. And what do? We multiply on the left by A inverse, and also do the same thing here on the left. It does matter. So it's the left multiplied by the inverse of A. And the inverse of A we can easily find with the calculator. And then these two gives us an equivalent of 1 for matrices, which is I. So I for 2 by 2 matrices is this matrix. Why is it called identity matrix? Because if you multiply this by any matrix that is allowed, you don't change it. That's why it's called I. It's like 1 times 3 is 3. So I times any matrix that legally you can multiply is going to give you the matrix back. So I times any matrix, including X, is going to be just X. So on the left we get X, and on the right we get this thing, A inverse times B. And that also gives you the answer. So let me do this with the calculator quickly. So what we want to do, we want to create this matrix in the calculator. So I'm going to go to matrix, and then go to maybe B, because I'm going to edit, and go to B. I can use A. Let me use A because we don't need it anymore. So we're going to have to change its size to 2 by 2. So that would be 1, 1, 1, and negative 1. There. So that's why matrix A. So I'm going to also go make matrix B like the matrix that I want. So matrix has to be 1 by 2 by 1, right? So what do I want it to be? 15 and 10. So put 15 and then enter and put 10. So if we take A inverse and multiply it by B, we would get the answer for this system. So let's see. So I'm going to go get matrix A, fetch it or put it on home screen. The way you find the inverse of a matrix with a calculator is by this. This doesn't mean 1 over the matrix. It's just the inverse of a matrix. If you put it on a matrix, that's what it means. So we want to take that and we're going to multiply it by matrix what? Matrix B. So let's go get matrix B here and enter. There. See, the answer is what? The answer is a matrix that is 2 by 1 and it's 12.5 and what? And 2.5. So that's how we can do it with inverses. All right, it's the same answer. And again, I'm going to just review these things because I'm sure you learned them in college algebra. Now, there is another one that the system, the books call it, let me bring it right here. So there is another method, it's called, why doesn't this work? So let's see, use my mouse. Okay, so it's called the Cramer's rule right here, Cramer's rule. Now, what is the Cramer's rule? The Cramer's rule has to do with something called determinant of a matrix. Now, the determinant of a matrix that is 2 by 2, so if you have a matrix, let's say A, B, C, D, determinant of a matrix that is 2 by 2 is given by AD minus BC. That's defined this way. And if you want to know why, if you write a system like this, AX plus BY equals to some number, and then CX plus DY equals to some other number, let's say, let's put F and G here. then if you try to solve this, with elimination method, you're going to end up with this idea that your x is going to equal to, in the denominator, you're going to have a times d minus b times c, ad minus bc. And for y, the same thing happens. In the denominator, you're going to have ad minus bc. And Kramer realized that if you define the determinant of a matrix 2 by 2 this way, then you can say that x is really nothing but what? Take the determinant of this matrix, right, in the denominator. And what is that matrix? It turns out that this matrix is actually a matrix of the coefficients. So if you think of ax equals to b that we were talking about, a is really a, b, c, d. So take the determinant of the matrix of coefficients, which is defined this way. Why is it defined this way? Because that's what they realize. That's what you get. So we get the determinant of a, right? Well, let me just put the letters in there. So determinant of a, b, c, d, and then y, the same thing. Denominator would be determinant of a, b, c, d, and determinant of, again, found this way. And then Kramer realized that the numerator is when you, in this determinant, right? So let's say we want to find the same determinant. So he realized that if you want to find x, then replace these with what we have. Replace these with these two, right? So what we do is we put f and g here. And then put this in the numerator. So that's the determinant. It's not a matrix. The notation for determinant is like absolute value. And then he realized that the y is given by the same determinant, but this time you erase that and put these two numbers in it, right? So a and b remain the same, but then you get f and g here. So that's called the Kramer's rule. So let's see if this works for our example. So what do we have? We have x plus y equals to 15 and x minus y equals to 10. So we're going to turn it into a matrix equation, right? And then this guy says that if you want to solve this, all you have to do is what? The x would be determinant of 1, 1, 1, negative 1. And then this would be, since we want to find x, we have to replace the first column by 15 and 10. And then this column remains the same. And then y equals to, denominator is the same, 1, 1, 1, negative 1. And then the numerator would be, we have to replace the second column by these numbers. So it would be 1, 1, 15, 10. So what's that? Well, remember the determinant is what? We said is AD minus BC. So you multiply this way first. It's called the main diagonal. So 1 times negative 1 is negative 1 minus 1 times 1 is 1. So that's negative 2, and the same is true for y. Now the numerator again is this minus that. So 15 times negative 1 is negative 15 minus 1 times 10 is 10. Negative 15 minus 10 is negative 25, and that's 12.5, which is exactly the same number we got before. And then this one, the numerator would be 1 times 10, which is 10, minus 15 times 1, which is 15, so that's negative 5, and that's 2.5. So the solution is 12.5, 2.5. Okay, So Kramer's rule can give us x and y. The inverse method can give us x and y. And so what we have is what is Kramer's rule, inverse method with inverses, and then Gaussian elimination. 3 different ways using matrices. All right, so, and we, of course, we use calculators to do this, right? All right, now let's look at some examples quickly, and then we go to 3 by 3. So let's look at some examples. Here we go. So we have some examples here. Let's say it says, for the following exercises, determine whether the given ordered pair is a solution to the system of equations. And I'm going to close this. I don't really need it anymore because this one is much easier to use. So it says, determine whether the given ordered pair is a solution or not. Well, that would be easy because all you have to do is what? Let's say this is the system, right? Oh, my pen is so big. Let's make it bigger. That's medium, it's good. So, so I have this system here. Let me rewrite it here. 5x minus y equals to 4. And then I have x plus 6y equals to 2. Now, the question is this a solution for that? For that to be a solution, it has to work for both of these. So if I put 4 for x here and put 0 for y, what's 5 times 4? 20 minus 0. That doesn't give me 4, right? So it's not true. And that's good enough. I don't have to check the second one. If it doesn't work for one of them, I say no. The answer is no, right? And you can do another one, and that's pretty easy. So, so that's how you do these problems. Let's do another one. It says, solve the systems using substitution. Well, we talked about that, so let's do one of these. There you go. So here's a system. So what do we do? Well, first of all, we could call the first one number 1 and call the second one number 2. And let's solve. You see, it's easy to solve for x here on the first one. So we solve for x in the first one. We get 5 minus 3y. And then we substitute it in the second one. So 2 times x plus 3y equals to 4. So my x is 5 minus 3y. And now I have 10 minus 6y plus 3y equals to 4. So 6y negative and 3y, that's negative 3y. Now move the 10 to the other side. That would be 4 minus 10. So negative 3y equals to negative 6. So y is, I said x, should be y. So y is 2, right? Now, if y is 2, what is x? So we're going to take that number. We're going to take 2 and sub y equals to 2 in equation 2 or in equation 1, doesn't matter. So let's do it in 1 actually. So in equation 1 we have x plus 3 times 2 equals to 5. So x equals to 5 minus 6, which is negative 1. So the solution is negative 1 and 2. So that's the substitution method that we talked about. All right, so I don't see really any one that is difficult, but let's do one with the calculator. Let's say we have something like that. I want to use a calculator to do that. So how do we do it with the calculator? Well, let me first have something to write on. There you go. So, there you go. So what I'm going to do is this. First of all, I'm going to write a matrix, augmented matrix. So the coefficients, you see, it have to be in order, right? X, Y, X, Y. If they're not, you have to order them. Okay, here they are. So negative 1/4, 3/2, and 11. That's the first row. The second row is negative 1/8, 1/3, and 3. And what we want to do, we want to convert that. We want to convert this to, if possible, 1001. And then we're going to get some number here, and that would be the solution. So let's see what happens if we do that. So, so we go to matrix, and then let's go to edit, and edit A as a matrix that is 2 by 3. So that would be, we want to put this matrix in, right? The first one. So we put negative 1/4, negative 1/4, 3 divided by 2, and 11. And that's negative 1/8, 1/8, and 1/3, and then 3. So that's that matrix. So I'm going to get out and go to matrix and math, find that RREF, not REF, RREF, and then put matrix A after it, then press enter. See, my solutions are what? So this matrix that I needed here is 1, 0, 0, 1, and then negative 8 and 6. There. So the solution is basically x is negative 8 and y is 6. All right? All right. Let's look at one that doesn't have, let's see if I can find one that doesn't have solution. See what happens. Here we go. So this one, let me wait for it to suck velocity. All right, here we go. Let's break out. Okay, so what happens if you get something like that doesn't have a solution? Well, the Gaussian method works them too. So let me go up and get back to that. So I'm going to do this one that doesn't have a solution here. There you go. There. So what happens when we use this method with something like that? Well, let's see. Negative 1, 5, 2, negative 10, negative 1, 6. So can we convert that? If it has a solution, we are able to convert it to something like that. Now, of course, it doesn't have a solution or has many solutions, then that's not possible. So what do we get instead? Well, let's see what we get. So we are going to create that matrix. I'm going to edit it. And we put negative 1, comma, 2, and negative 1, 5, negative 10, 6. There. So now we make sure we did it right. Yes. So what we want to do is the same thing I just did. I go to matrix and math and find RREF and put matrix A right after it, and then press enter. See what we get. Instead of that, we got what? We got 1, -2, 0. We got 0, 0, 1. So now this tells us that if we write this back as a system, you see what it looks like? It's going to look like 1x minus 2y equals to 0, and then 0 times x plus 0 times y equals to a number. Now, this is not possible because you can't have any two numbers that you multiply by 0 and you get this number here. So what happens if you have no solutions? How can you tell from Gaussian elimination? Well, in the Gaussian elimination, the last row will be all 0 except for the last one, which is the right-hand side here. Right? If you get a row of zeros except for the last one, that means no solution. So this one has no solution. Now, what happens if you have many solutions? So the next problem actually is many problem. Oops, right? Oh, where are you going? Well, we need one with many. Here you go. This one has many solutions. So let's pick this one and see what happens. Well, let's see. So here is the system. Wait a minute. Did I pick everything? No, I didn't. There you go. So let me pick all of it. Okay, so this is the system. So what we want is 7, 6, 2, and -28, -24, and -8. We want to convert it to that form if possible, right? Now let's see what happens if you put it in a calculator. We'll put it in the calculator. We're going to end up with edit, and so that's 7, 6, 2, -28, -24, -8, right? Now we're going to go back to, first you have to quit, make sure you're in home screen, and then go to matrix and math, RREF, matrix A, enter. So we ended up with, let me change the mode to only one decimal place so we don't have a long bunch of numbers. So let me do this again. So you see, it's one decimal place, so I don't want to have all those decimal places. So the matrix is right here. So the matrix is basically 1, 0.9, 0.3, and then 0, 0, 0. Now we can convert, instead of the mode, let me change my mind. I'm going to go to float again. That means many decimal places. And I'm going to do this again, press enter. Now what I'm going to do, I'm going to convert it to fraction. See? So convert to fraction. So I get it in terms of fraction is better. So that's what I'm going to do. I'm going to convert it to fraction. So in terms of fraction would be 6 over 7 and 2 over 7, and that's it. That's what we get. So again, to convert to fractions, you go to matrices, you go to math, you get your RREF, right, and you get your matrix in there. And once you find it, then go to math and convert to fraction. Press enter twice. Okay, so what does that mean? What is the solution? Well, whenever you have rows of zeros in Gaussian method, it means infinite number of solutions. Now, obviously, if you have only two equations, you have one row of zeros. And if you have all zeros, you see the difference here? This one is 0, 2. Now, if you have a row of zeros, that means what? That means many solutions. And how do we get all the many solutions? It's easy. Convert this back to a system. So write it as 1 times x, right, plus 6 over 7 times y equals to 2 over 7. Now, that means all the solutions are given this way. So you can do it again this way. Write x and y such that x plus 6 over 7y, 6 over 7, 6 over 7y equals to 2 over 7, like that. Okay, so that's one way to do it. Another way to do it would be this way. You say, okay, I know this is the case, right? So why don't I just solve for x here? So say x has to equal to what? 2 over 7 minus 6 over 7 y. So y can be anything, x has to be that, right? So sometimes the solutions are given like in ordered pairs vertically this way, and sometimes they're given horizontally this way. So horizontally, y can be any number, then x has to be 2 over 7 minus 6 over 7y, right? Or vertically, you could say y can be anything, and the x would be 2 over 7 minus 6 over 7y. Okay, so that is a solution. That's another way to write it. Okay, so there are systems that have one solution, systems that have many solutions, and systems that have no solutions. Now, how does this work if we have a 3 by 3 system? Well, let's look at some. It doesn't really, everything is the same, nothing really changes. And just let me close that one so we have use less memory here. All right, so 3 by 3 system is the same thing. For example, here we have what? We have 3 numbers such that if you do all these to them, you get 1. If you do all these, you get -2. And if you do all these, you get 10. Now, it's kind of hard to do it in your head, obviously, so we don't do it that way. What do? We use a calculator. Now, geometrically, what does that mean when you do this? Well, geometrically, let me show you what it means geometrically. So let's look at an example. Let's see. We can do an example. So this one right here. So this one right here, this is a solution for that. So let me use GeoGebra and graph this in 3D, right? So what I'm going to do is I'm going to graph this in 3D. Now with GeoGebra, you can graph in 3D. If you change the view to 3D, then should get 3D view, see? And then what I'm going to do, I'm going to draw the equation, just put the equations here. 2x minus 6y plus 6z equals to -12 there. Oh, what am I doing? Oh, my keyboard language is off. There we go. All right, 2x minus 6y plus 6c equals to negative 12. And that's, now notice what we get. If you have three variables and you graph it in 3D, you get a plane like that. In 2D, with two variables, you get a line, but with three variables, we get a plane. You're going to study 3D in Calculus 3, but here, basically, this is the x, this is the y-axis, and that's another extra axis y. If you graph something 3D, if you graph something with three equations, that's actually a 3D object. So let's graph, and these are all going to be plane. If the powers on x, y, z are 1, they're going to get plane. So x plus 4y plus 5z equals to negative 1. That's another plane. And then the last one is negative x plus 2y plus 3z equals to negative 1. There. So notice that this solution here, which is what? 0, 1, negative 1, that solution is basically where these three planes intersect. So let me turn off the plane on the xy plane. So we only have what? We only have the three planes. So I'm going to turn off and graph them one at a time. So you see, that's a plane, right? You see? And here is another plane that intersects that plane, right? In a line, see? They intersect at that line. See that line right there? All right, now I'm going to graph the third plane. Let's see, there we go. There. And you see that third plane also intersects both of these planes, but there is a point that all three intersect. You see that point? There is a point. Let me get a good angle at that. Yes, it's right there. See? Right there. And that point is the solution. So geometrically, that's what's going on. But how do we do it with the calculator to find that answer? We do the same thing, except this time. So let me get, there we go. Let me get an area I can write on. So basically what we want to do is the same kind of stuff, except here, what we want to do, we want to make a matrix that has 3 rows and 4 columns. And again, make sure these are in order, right? Make sure that these variables are in order. So we got 2, negative 6, 6, and negative 12. And we have 1, positive 4, positive 5, and negative 1. And we have negative 1, 2, 3, and negative 1. There. And we want to convert that to what? To 1 for x and 0 for y and z, and then some number here. And then 0 for x, 1 for y, and 0 for y, and some number here. And then 0 for x, 0 for y, and 1 for z, and some other number here. We want to convert it to that. And we know how to do that with the calculator. So we are going to turn it on and go to matrices, go to edit, pick the first one. Now we want to make it 3 by 4 and then put 2, enter, 2, enter, and then negative 6, enter, and then positive 6, enter, then negative 12, enter, and it should move to the next row automatically. So we need 1, and so we need to clear that and put 1, enter, and put 4, enter, and put 5, enter, and then negative 1, enter, and goes to the third one. Again, we have negative 1, enter, we have 2, enter, 3, enter, and negative 1, enter. All right, now I want to get out of here and go to matrix and math and pick the same RREF, and then we're going to put matrix what? Matrix A in there and press enter. There. So we got the solution in a second. So it's 1 0 0 0 0 1 0 1 and 0 0 1 negative 1. So the solutions are right here. This is x, this is y, and this is z. Right? And that's 0 1 negative 1. So it works with the calculator. Again, if you get here all zeros, if you get all zeros except the last one, that's no solution. If you get all zeros and then one row completely zero, that means there are infinite number of solutions. So let's do one of those, and then I'm going to make another video talking about nonlinear systems. Okay, so it would be chapter 9b. Okay, so we'll look at one that has many solutions, an OR. So let's see if we can find one that has many solutions. No, this has one. Oh, here we go. So this has infinite number of solutions. So if we do it, we get what? We get infinite number of solutions. So let's see how we deal with that. So now we can put the matrix without really writing it down, but I'm going to write it down here. So make sure these are in order, right? There are. So we're going to put what? We're going to put 2, 3, negative 6, 1, and then negative 4, negative 6, 12, and negative 2. This has to be a little bit longer. Let me make it longer. I don't know why my... Here we go. So let's make it longer. So that would be 1, 2, 5, and 10. So that's my matrix. So let's make it. So I'm going to do the same thing. I'm going to just edit that one. So I need 2, 3, negative 6, and 1, negative 4. Oops. Oh, what did I do? Did something wrong. Go to it. All right, so that was correct. We got to 2, 3, -6, and 1. That's correct. So we go down. Let's see. That should be -4, and that should be -6. That should be 12. That should be -2. And that should be 1 and 2 and 5 and 10. All right, so now let me make sure we have the right matrix. Press enter. No, something is wrong there. Oh, here we go. 10. Enter. All right, we have to get out and then go to matrix. So 2, 3, -6, 1, -4, -6, 12, -2, 1, 2, 5, 10. Yes. So now we're going to go to matrix and go to math and get RREF. Put the matrix in there. And we have, yeah. So what we get is, 1, 0, -27, -28, 0, 1, 16, 19, and 0, 0, 0, 0. So that right away indicates that we have infinite number of solutions. Now the question is, how do we write them? And the answer is, well, you have to turn this into a system, back into a system, which is going to have only 2 equations, because this one has all zeros. So our system turns into what? Turns into 1x, 0y, we're not going to write it, minus 27z is going to equal to -28. And now this is 0, so 1y plus 16z equals to 19, and that's it. Now the question is, how do I write the solutions for the system? Well, we can let x be a free variable and find z. Now I have that already here. If you do that, you get this. So what I'm going to do, just to have another example, I'm going to let z be the free variable and solve for x and y, which is much easier here, right? So what I'm going to do, I'll let x be what? So if I solve for x here, right? If I solve for x, just have to move this to the other side. So x is going to be -28 plus 27z, right? And from here, y is going to be what? Y is going to be 19 minus 16z. And my solutions is going to look like this. You see, that's one way to do it, if you let x be free variable and solve for z and y in terms of x. But it's easier, as you see, to let z be whatever z wants to be, and let x be what? -28 plus 27z, and let y be what? 19 minus 16z. So we get the same answers. Let's say, for example, if x is 0 here, what do you get? You get 0 and 65 over 27, and you get 28 over 27, right? Now, if you let z be 28 over 27, this is going to be 65 over 27, and this is going to be 0. You see, if I substitute 28 over 7, right, for z here, 28 times 28 over 27 is going to be 28. 28 plus negative 28 is 0. So if you do that, you get the same answer. So this answer and this answer and this answer are basically give you the same solutions, right? Except that here z is free and here x is free, right? You can let x be whatever number and you get the rest of them. Here let z be whatever number and get the rest of it. Now because of this, sometimes you see that instead of using z, x, or y, we use another parameter. We use another letter, like 28 plus 27t and 19 minus 16t, and then we let that be t instead of z. And over here too, you can just let it be what? Let it be t, and then 65 minus 16t over 27, and then 28 plus x plus t plus t over 27. So you can even write it like this or like this. So these are the same. All right, so the next video I'm going to talk about systems that are not linear, not systems of linear equations. It could be a mixture of linear and nonlinear. So next time we're going to talk about that, okay? So until next time, I'm going to see you in the next video. Until next time, okay?